Assalamu alaikum warahmatullahi wabarakatuh. Good evening, and I have come with another video about basic physics of radiation damage production. And yes, here our presentation will start. What basic phase physics radiation? And yes, we can start the presentation. Sorry, we had an internet connection problem. And this presentation is about basic physics of radiation damage production. And for the introduction, radiation damage in solids, overview of how radiation affects solid materials, importance in various fields from astrophysics to nuclear technology. The significance of studying radiation damage in materials, particularly in nuclear materials, it outlines the objective of the paper, which include reviewing various simulations, methods, and their applications in understanding damage production. And radiation in nature and technology, natural radiation. There are 2 points: cosmic rays and radiation from stars, radiation from radioactive elements in Earth's mineral. And next is technological applications, nuclear power, ion beams, and radiation processing in industry. And if we take the theoretical background, discusses the fundamental concepts of nuclear interactions, including the definition of interactions across sections, which measure the probability of events occurring per unit path length. It explains how these concepts are crucial for understanding the rates of nuclear reactions and the implications of radiation damage. And what is the basic theory of cascades? Examines elementary cascade theory, which describes the energy transfer that occurs when rapid particles collide with target atoms. The significance of recoil energy spectra and their connection to the creation of material damage are emphasized in this section. And what is the radiation effects in solids? Primary knock on atoms, pKa. pKa's are and how they cause displacement in solids, energy transfer through elastic collisions, damage production, cascades of displaced atoms forming from a pKa. And what is collisions and cascade? The collision cascade theory, how energy from radiation is transferred between atoms, Qualistic collisions and energy distribution, limiting factors on atom displacement. Radiation damage is studied using a variety of computer simulation techniques. It draws attention to how the high computational needs of molecular dynamics models limit their statistical potential. The use of these techniques is to comprehend damage mechanisms is also covered in this section. And what are types of radiation damage? Ionization and structural effects, and sputtering and surface damage. If it is the first one, distinction between structural and electronic excitations, formation of defects like vacancies and dislocations. And the second, how high energy recoils can cause surface erosion. And atomistic simulation models, molecular dynamics, binary correlation approximation, BCA. And what were the key findings of this research? Energy dissipation, methods of energy dissipation, ionization, collisions, difference between energy deposited in atomic motion and electron excitations. And what is damage modules? Kinchin piece model for damage prediction, limitation of classical models in predicting actual damage levels. And for the conclusion, if we take relevance of radiation damage research, importance for nuclear power safety materials since science and technological development, the ongoing need for precise simulation models to predict radiation effects on materials. It makes recommendation for future lines of inquiry and the possibility of developing better models to deepen our understanding of how materials behave when exposed in radiations. And thank you for the for this presentation. And let's meet in another video next week.